The objectives of this course are to learn what is communication, what are all the types of communication, various analog and digital modulation techniques, what is information, how to find out how much information in data, various coding techniques, and various multiple access techniques in communication systems. So today in this lecture, I'm going to talk about what is communication, what are all the basic building blocks in the communication system, what is modulation, and why modulation is needed in the communication process, and finally, what are all the different types of modulation techniques. What is communication? Communication is a process of exchanging the information between 2 points which are far away from each other. Here, information could be voice, image, even video. So, through the basic block diagram, let us understand how the information is exchanged between 2 points. There are three basic elements in every communication system, namely transmitter, receiver, and channel. So in the transmitter side, there will be a sensor like microphone. It captures a non-electric source like sound and it converts into an electrical signal. This type of sensor is called as input transducer. Suppose if you want to send an image, in the transmitter side there will be a camera to capture light and it converts into an electrical signal. Once a source signal has been converted into an electrical signal, the transmitter will modify the signal into a suitable form for efficient transmission by applying filtering, amplification, and modulation techniques. After the signal has been modulated, the signal it is ready for transmission. After modification, the signal is given to channel. The channel is a transmission medium through which the signal travels. There are two types of channel. One is wired channel and another one is wireless channel. If there is a physical connection between transmitter and receiver, then the channel is called wired channel. If there is no physical connection between transmitter and receiver, then this type of channel is called wireless channel. In wired channel, the medium may be optical fiber or coaxial cable. And in the case of wireless channel, the transmission medium may be air or water. Then we have a receiver. Receiver is used to receive and reconstruct the signal by applying filtering, amplification, and demodulation technique. Finally, there will be output transducer to convert electrical signal into original form. If mic is in the input side, there will be a speaker in the output side. And if camera is in the input side, there will be a display device in the output side. If there is a keyboard in the input side, there will be a monitor in the output side. So this is a process to transmit any type of information in any type of communication. There are some basics you must know before entering into the subject of communication engineering. First one is, what is signal? Signal is a physical quantity carrying some information with respect to time or any other independent variable. Here you can see one speech signal. Your speech signal also will be like this. I'm taking one example of audio waveform hello world. If you say hello world, the variations will be like this. So this is an amplitude variation with respect to time, and this is a frequency as well as power variation with respect to time. Next one is frequency. In a signal, frequency is a number of complete cycles per second. A complete cycle means both positive and negative cycle. The standard unit of frequency is Hertz, abbreviated Hz. If complete cycle per second is 1, then the frequency is 1 Hertz. If complete cycle per second is 1000, then the frequency is 1000 Hertz or 1 kilohertz. We can convert one frequency value into a standard form. For example, I am taking 1000 cycles per second. We can write 1000 Hertz. Here we can count the number of zeros 1, 2, 3. So 3 zeros. So we can write 1 into 10 power 3 Hertz, or 10 power 3 means kilo. So we can write 1 kilohertz. Similarly, 10 power 6 means mega, 10 power 9 giga, 12 tera, 15 peta, 18 exa, 21 zeta, 24 eta. And next one is wavelength. Wavelength is the distance between identical positive peaks of a signal. Okay, positive peak is also called crest. Wavelength is denoted by lambda, and the unit of the wavelength is meter. Then how to convert any wavelength value into a standard form? For example, I am taking 0.001 meter. This is, we can write like this: 0.01 in 10 power minus 1 meter, 0.1 into 10 power minus 2 meter, or 1 into 10 power minus 3 meter. If 10 power minus 3 means, we can write milli, minus 6 micro, minus 9 nano, minus 12 pico, minus 15 femto, minus 18 atto, minus 21 zepto, minus 24 yocto. There is a relation between frequency and wavelength. Wavelength is equal to speed of a signal in a medium divided by its frequency f, lambda equal to v by f. Suppose I am taking one example here. If the frequency value is 100 megahertz, means what is wavelength? We can find out. There is a formula, lambda equal to v by f. V is the speed of the signal in a medium, that is 3 into 10 power 8 meter per second. The frequency f is 100 megahertz. Then substitute this v and f, we can get the lambda value is 3 meters. And the one more important thing is, you must know what is radio spectrum. Radio spectrum is a part of the electromagnetic spectrum ranging from 3 kilohertz to 3000 gigahertz. Here, electromagnetic spectrum means it is an electromagnetic radiation from 1 hertz to 10 power 24 hertz. Spectrum means it is a range of frequency. Where we can use this radio spectrum? The important application of this radio spectrum is telecommunication. The spectrum is divided into different frequency bands, and each band is allocated for a specific application. For example, from 3 kHz to 30 kHz, it is for radio navigation, and from 300 kHz to 3 MHz, it is for AM radio. For example, All India Radio Tiruchirappalli Vanuli Nilayam, and from 30 megahertz to 300 megahertz it is for FM radio, for example 100.5 Kodai Panbalai, and from 300 megahertz to 3 gigahertz it is for the application of 2G, 3G, 4G and GPS, and from 3 gigahertz to 30 gigahertz it is for satellite communication and Wi-Fi communications. So similarly, for each applications there is a band is allocated. That band is fixed, that is allocated by ITU, International Telecommunication Union. The next one is bandwidth. Bandwidth is a difference between upper and lower frequencies. It is typically measured in hertz. We can find out how much bandwidth is allotted for satellite communication and Wi-Fi. In this case, the upper frequency is 30 gigahertz and the lower frequency is 3 gigahertz. So the bandwidth is equal to 30 minus 3, 27 gigahertz. And let's come to the subject. The first topic is modulation. Modulation is a process in which the characteristics of carrier signal is changed in according to the amplitude of the modulating signal. In any signal, there are three important parameters: amplitude, frequency, and phase. Here, the characteristics of the carrier signal is changed. Carrier signal means it is a very high frequency signal used to carry modulating signal information. And the modulating signal means it is a message or information signal that is going to modulate the carrier signal. So here the characteristics of the carrier signal is changed according to the amplitude of the modulating signal, that is called modulation. There are two types of modulation. One is analog modulation, another one is digital modulation. What is analog modulation? If the modulating signal is analog means continuous, then the modulation is called analog modulation. Digital modulation, if the modulating signal is digital in terms of zeros and one, then the modulation is called digital modulation. So in analog communications, there are three types: amplitude modulation, frequency modulation, and phase modulation. What is amplitude modulation? If the amplitude of the carrier signal is changed, so this is a carrier signal, the amplitude of the carrier signal is changed according to the amplitude of the modulating signal. Here you can see the variation of amplitude of the carrier signal. So this is actual carrier signal. So this is after modulation. After amplitude modulations, the variation of signal looks like this. So the amplitude of the carrier signal is changed according to the modulating signal. This is called amplitude modulated signal. And what is frequency modulation? The frequency of the carrier signal is changed. Listen, this is a frequency modulated signal. The frequency of the carrier signal is changed, not in voltage. According to the amplitude of the modulating signal, this modulation is called frequency modulations. So in your home, if you are having AM radio, so the received signal will be like this. And if you have the FM receiver, if you tune to Suryan FM, the signal will look